Hello, everyone. I hope you had a wonderful holiday. Um, so let's start with the schedule. We have 4 classes. So I hope you can finish the project 2 in this week, so that in the final week you may have more examinations, and you just do submit your results or do a presentation in the final week for the project 2. Today, I will talk about more on project 2. And I will also answer the questions on project 2 in this class and the class, the next class in this week. So please finish the OCQ first. I think the OCQ has been enabled, so you can input your feedback even now. About final examination. Don't worry, I will post this PDF online. You can click the link after this class. So about the final examination, because the final examination we have more questions, which are not exactly the same as the review. So the average credit is lower than midterm. In midterm, most students get 80 something. Several get 90, but this time no one get 90. So I decided to increase the weight of project 2. So now project 2 cost 20 points. This is a solution for the students who did not do a good job in the final examination to increase their credits. So if you get 20 for the project 2, in the project 2, it has a less impact if you have a higher credit in the final examination. If you get a 20, which is a full score or full credit in project 2, it's more helpful if you get a lower credit in the final examination. So if you want to have a better results to reduce the negative impact of final examination, you should be serious about the project 2. The project 2 is asked you to implement some replacement policy, cash replacement policy. Here are 3 examples, which is not most recently used, pseudo least recently used, and random. And if you want to achieve higher credits, which is not included in the 20 points, you can also implement a prefetch policy. So the upper bound of the credit of a project 2 can be larger than 20. So here is the results of some benchmarks. This is the hit rate result. Of course, the LRU can achieve the highest.
Is this the hit rate for L1?
Yes, it's a L1.
Okay, thank you.
And you can try L1 and L2. I received some email from the students who actually complain about the code. So I will repeat, how can you compile the code and execute the code on Windows machine. Because I believe if you using Linux, you should have no problem at all. Because the compiler and the command line, you should be very familiar with the command line or compiler in Linux. So let me share my. So you can install the IDE, C++ IDE first. I will share my IDE. So this is the IDE. You can download the source code I posted on Canvas and then unzip the code. The first thing you can do is to build a project. And then you can choose the console application and then go and then choose C++. And then you can new project 2, which is so-called a project 2. And
is this the same step like using G++ in Linux to make the a.out file?
I will, if you have a question, I'm very happy to explain the Linux, also Linux in this lecture.
Well, I mean, is this that same step?
That's right. That's right. I will give you more details on Linux part after I do the explanation on Windows. So for Windows, we can name it as project 2. And the next. And the next. Now the IDE actually create a main.cpp for you, which is a very simple dummy application. Just print a hello world. Now you can copy the content of that CPP. We have a cache. We only have one source code, which is a CPP file named cache.cpp in the source code. So you can copy the content of it to this main.cpp file. So you just replace it in this project. And then that's all. And then you can compile the code. How to compile the code? This is the button to compile, to build the code. And then you can see that the code has been successfully built. And then you can input the image file and the trace file. First, you need to do is click the project button, and then set the program's arguments, and then choose the debug, and then copy the file like this. So the information I put into this box is the location of the image file and the trace file. We put the image file first and then the trace file, and then click OK. And then we can, after we build the code, we can run. So now you can, I'm not sure you can see now after you click the run button, you can see the output. So I just print out the L1 hit rate, L2 hit rate, and L3 hit rate. This floating point number is the hit rate. And we also have an integer at the end of each line, which is the total access number. You can see the code about these informations. Any question?
So our job after this is to basically just go down your code and implement the following, MRUs, LRUs, the ones that you want.
That's right. That's right. I actually, wait a second. I actually back to the shared screen and back to the PDF. So this is the PDF. You can download the IDE, and then you can build. You can set the arguments, program's arguments, and then you can run the code, and then you can get the output. I don't think this project is difficult. Why? First, I give you the example of the source code on the LRU, which is the least recently used. Now the least recently used policy has been implemented in the code. I think this is the most difficult policy compared to the random and not most recently used policy. I will explain the code again. So some students ask, what cache type is the cache.cpp that use supply? What does that mean? The file includes 3 levels of cache, L1, L2, and L3. All the cache levels are in the same file. So we only have one source code file, which is cache.cpp. No, the assignment is not to ask you to rewrite all the codes of each version. We supply the LRU. You can implement your own random policy and not most recently used policy. You only need to implement 2 types of new replacement policy. And also, if you like, you can also continue to do the prefetch. That's right. I have already provided the LRU implementation in the file. I will explain the code for you. So basically, we have some request data structure, which is so-called elements. In these elements, we have a variable indicator whether this is a read or write. The NCC indicator whether this is a read or write, and then the address indicated the address of this read or write. And then we have some cache set data structure. We have some upper level cache structure, which includes multiple sets. In the sets, I think the most important variable is this counter, replace counter. I don't think you need to modify the cache line size, or associativity in the cache data structure. But this replacement counter is the most important variables. I provide you some basic function, which is you can convert integer to binary by this function, and then you can find the data in the cache by this function. You can update the counter, the replace counter, by this function, and then you can do the replacement in the replace function. I will give you more details on this part for the LRU replacement policy. So here is one example. So the counter A is actually, you can see the counter A as replace counter. But here, for short, I just write counter A. At the beginning of the application, all the counter are 0. And then once you have a request, read a request, I increase the value of all the counters here. And then you visit a cache, you find the content you want, you find the piece of data you want in the cache. And then we set the most recently used, the least recently used. I'm sorry, I made a mistake here. And then we send the most recently used, the data you just visited, the counter to 0. When you have another request, we increase the counter again. So because you just access this counter, so the value of this counter is 1. Because originally when you do the access, the counter value is 0. And all the other counters just plus 1. And then we access A2 again. We set here again, this is the most recently used to 0. This is to 0 again. And then once you have the third, now you have the third request, I increased all the counters. Because you just access this counter, so this counter value is 1. All the other counters are just plus 1. In the third request, it accessed A1, so this request. So we set again, this is the most, I made a mistake, most recently used value here to 0. And all the other values just plus 1 here. In the fourth request, I accessed A3, and this value is 0. Set this value as 0. So you can see that if this counter, if this address have been heavily accessed, the value of this counter must be small. During the replacement policy, if we want to evict something, we must pick up a counter with the largest value. Because if you have a largest value, it indicates that you are less frequently accessed. Okay, some students ask, how can you get the counter of most recently used? Once you find, when you have access, you need to look up your cache. Once you find the content, that's the most recently used cache line, right? After you just access this line is the most recently used line. Okay, by this function, you can find that part. And again, this update function help you to increase the counter here, plus. And this sentence set the most recently used value to 0. And then the replacement policy just pick up the counter with the largest value. I made a mistake here. This is the most recently used. Okay, I will modify this after this class and upload the correct version of this implementation. So in this way, we can mimic the least recently used implementation. This is not the real least recently used. That's the reason why we call it a pseudo. So I think for the not most recently used implementation, which is simple, you just during the replacement, you cannot replace the value with the counter with the smallest value, and then you can pick up any other counters, right? So during the least recently used policy, you pick up the counter with the largest value. The largest value indicate this this counter has been the least frequently used. But in the not most recently used the scenario, the replacement policy, you can pick up any counter except the counter with the smallest value. That's the difference. That's the only difference. For the random one, you just generate a random number and then you can replace that. That's all. I don't think this project is difficult at all. So during my access, you can do the lookup here. If it's a heat, you get a true, you get an index with a non-1 value. Otherwise, the index is -1, which indicates you have a miss. If you have a miss, you have to fetch a new line to the cache, and you need to evict a line in the cache. That's the timing when you should do the replacement policy. And then these are some free-flow codes which can help you to read the source code, read the image file and the trace file. So this simulator is not complicated at all because it includes only one file. I believe it's less than 100 lines in the code. For a real simulator, it includes a lot of files. This is one example of the real simulator. Even the config file of the real simulator is more complicated than our cache simulator. Before the Q&A, I will introduce how to handle the code on the Linux machine.
I think I can help the others with that. That's not a problem because it's very straightforward. I wanted to ask about teams because in the first class that we had at the starting of the semester, you said, I think in the slides it said that we can have teams for the final project. Is that still a thing?
Yes, you can. Of course.
And what's the maximum team size?
2.
Okay. And I also had another doubt. So with the different tests like A* and libquantum, are there specific numbers that we should hit with our implementations?
No. I don't actually know the miss rate or hit rate of those benchmarks. I think the most important issue is to have the relative improvement. Of course, the least recently used policy is the best, and the random should be the worst.
And for the code that you gave us, the LRU code, in Leslie 3D, the test, I get like L2 and L3's NAN. Um, is that to be expected from the thing?
Yes, I think so. Some benchmark have very extreme behavior. That's the reason why maybe you need a more advanced prefetch code. Any other questions?
Professor, just so I'm understanding completely correctly, you basically just have to go down your code and alter it so we can implement the following NMRNU and the the random LSU.
That's right. That's right.
Because
You
you
only
already
needed
did.
to change. You only needed to change the function of find, update, and replace.
So just change the function of find, update, and replace. Okay.
Yes. If I were you, that's all three functions I needed to change.
Okay. And then do we completely change those, or do we just alter them slightly based off of the code that you've already given us?
I think it's a slightly you can only slightly change it. You need
Okay.
to only slightly change.
Okay. Okay. Thank you, Professor.
No problem. So I hope you can see the screen. So now I download the code to this directory. I unzip the code. Now I have the cache.cpp and the trace directory under the project2, the project2 directory. On Linux, you just use C++ to compile the CPP, the cache.cpp. So you have a out binary. Wait a second. A out binary, and you can use this A out to run the code. Now let's try the A star. Let's see the image. Put the image file first, and then the trace file. And then you can get the L1 heat, L2 heat, and L3 heat. And you can also do some editing here. Basically, they are the same. Honestly, in Linux environment, it's simpler. You can do some modification here. And then recompile the code again. Try the MCF. There's no MC. Okay, I have no MCF. Let's see. Yes, I also get the hit rate as well because it has very small footprint. Any other questions? If no question, we can stop today. If you have more question, please email me. And we can also discuss those questions next class. Yes, the presentation should be very simple. You just present your results. If you have a team, if you have a collaborator, you should introduce which part is implemented by you and which part is implemented by the other one. Okay. do not worry about the presentation. You just present some results you have. Any other questions?
So it should be like in graphs, like you like, should we show for L1, L2, and L3, or should we just make graphs for L1 like you showed us in the presentation?
You can do either way. You can just print out everything. That's fine for me.
Okay.
Yes, you can do groups, group of 2. But again, if you want to achieve a better results, you should do it alone. We have a higher requirement on the group. Any other questions? If no question, we can stop today. Thank you very much.
Thank you.
Thank you.